Hello, Mr. Geisler here, and we're going to look at question number 3 on homework number 6 of chapter 7-8, dealing with the Markov chain. In this question, it says, a local two-year college found that students flunked out 23% during a given year, had to repeat a year 10% of the time, and successfully finished the year 67% of the time. How many states will there be in this matrix? Well, if you read the next sentence, I tell you that there are 4 states in the matrix, so we can just go ahead and put that in there. And the 4 states of the matrix are just what can possibly happen from year 1 to year 2. Now, on the side is where we always put the from. In other words, where are you starting at? So we have the option of the first year of college, the second year of college, you would flunk or you would graduate. So those are the 4 different options from the first year. Over here, we have the 2. So you go from someplace to someplace. And again, it will be the first year, the second year, you can fail or you can graduate. Now, if you start in year 1, there are really only 3 things that can happen. You can flunk 23% of the time. So that's going to go in here as 0.23. You can repeat the year 10% of the time. So in other words, I can go from year 1 and have to redo year 1 again the second year. And that's going to happen 10% of the time. And then if I'm successful, which I am 67% of the time, that means that next year I will be in year 2. So if you start from year 1, you have 3 different things that could happen. You could repeat year 1, which happens 10% of the time. You could move on to year 2, which happens 67% of the time. Or you could just fail, which will happen 23% of the time. Now, since it's a 2-year school, after the first year, there's no way you can graduate, so that would just be 0. Now, if you start in the second year, you can still flunk out, and you'll still flunk out 23% of the time. You still might repeat it, and you repeat it 10% of the time. But since you start in the second year, if you repeat, you're repeating in the second year. Now, you will never go back to year 1 because you've already successfully completed year 1 if you're in year 2. Now, if you're successful year 2, that means you graduate. And we are successful 67% of the time. So the next thing we're going to do is what happens, if you fail. Well, if you fail, that means you're done. You're not going to be in year 1, you're not going to be in year 2, you just fail, and you're not going to graduate. If you graduate, well, there's no reason to do year 1, there's no reason to do year 2, you didn't fail, you graduated. So that's what your transition matrix will look like. So now what the next question says, in the long run, what is the probability that a freshman will graduate, and round that to 1 decimal? So that's where we have to use our initial matrix. Well, our initial matrix is always going to be a 1 by something. In this case, it'll be a 1 by 4 because we still have first year, second year, failure, and graduate. And now what's going to go over here is just going to be the first year because I want to know if you're a first year student, what it is the probability that you will graduate. So I'm a first year student, so I'm just going to put 1 there. That means 100% of these people are first year students. There's no second year students, no failing students, and no graduating students. So my initial matrix will look something like that. Then what we want to do is we want to multiply that by my transition matrix. So that'll be 0.1, 0.67, 0.23, 0. All I'm doing is I'm taking this matrix and writing it again down here. So this will be 0, 0.10, 0.23, 0.67. Then we have 0, 0, 1, 0, 0, 0, 0, 1. And then you're going to multiply them out. So what that means is you need to put them in your calculator. So you're going to take your graphing calculator, which I'm assuming you know how to put in matrices at this point, and then you're going to do this multiplication. But I want to know what happens in the long run. In the long run means we have to raise this second matrix to some power. We usually say 100 is a long enough time to do the long run. So when you put that in your calculator, you're going to get a 1 by 4 matrix that'll look something like this. Now, when you're doing that 1 by 4 matrix, I'm just going to round these numbers. Now, the first entry in mine is just 0. So 0% of the people in the long run will still be in their first year. Now, the next number according to my calculator, and I'm just going to write this up here for a second, it says 6.7 e to the negative 98. That means I want to take 6.7 times 10 to the negative 98th power, or in other words, it would be a decimal with 97 zeros and then 7. Anytime you see a big number that's negative after an e, that really means 0. So my second number is 0. So in the long run, you're either going to fail or you're going to graduate. You're not just going to keep doing year 1 or year 2 over and over and over again. So the next number, if I round it, the next number here is going to be 0.4458. Well, this one we want to round to one decimal point, so that would be 0.446 if I want to do a percentage to one decimal point, or 44.6. Now, that's the number of people that will fail. So 44.6% of the people fail in the long run, which means if we look at the rest of this, about so this is fail here, and then for this one is graduate. So graduate would be about 0.5542 about. So that means I'm going to put in here 0.554. So that means 55.4% of the students will eventually graduate. So I'm just going to write that in there. So that's how you do this question.